Hi, welcome to today's demo of HighJump test automation for implementation and regression. My name is Kaya Magumela from IWMS Quality Assurance. Today we're going to ask ourselves the question, why automate? Let's have a look at some of the reasons why. One of them is the fact that it saves time, cost, and manpower. The other is obviously the fact that applications grow and increase in complexity, making it more difficult to manage these errors manually. The other reason is automation removes the need for repetitive work, which is great, and removes the cumbersomeness of testing. Now there are a couple of reasons, but today we're going to focus on the key two that follows. To build a regression pack. Building a regression pack is a key element to test automation. The idea is to accumulate this over time. Once this is accumulated, you've got a solid representation of the scope of your system as well as your test coverage. Now the other is change management. And although the two are sort of interlinked, on the one hand we focus on accumulating the regression pack, and during change management we focus on making sure that pre-existing functionality has not been compromised. Now on the screen is a tool called FitNesse. On the right hand side is the HighJump virtual terminal. And we're going to use FitNesse to script our various HighJump processes and execute each and every test step to make sure that everything still functions the way it's supposed to. Now let's have a look at a typical FitNesse script in this case. The script starts off by connecting to the environment, including HighJump, using these parameters. Using the keyword verify text present, FitNesse verifies that this text is present on the HighJump virtual terminal. Using the keyword enter, FitNesse passes this parameter on the HighJump virtual terminal. And so the script goes on. Below here, as you can see, we've defined a couple of variables. These are variables that we will use within our script. The script goes on, goes into the particular process that we're testing in this case, executes the process, completes the transaction, and at the end, by means of using an SQL script, FitNesse connects to our underlying database and running this SQL script against the database to verify that all our database updates happen correctly in this case. And for the purpose of this demonstration, we're going to execute an entire test suite. We're going to start off by doing an ASN receipt. Then we're going to do a blind receipt. We're going to do an inbound order receipt. We're going to put away an LP. We're going to do a staged PO receipt at the end. Now let's minimize FitNesse so we can actually see our virtual terminal. There you go. Here's our virtual terminal right there, so we can see it in action. And we start off our test suite. Hit on the word suite. Now the suite runs, picks up the first script, which is ASN receipt. By using the HighJump process ID, the script connects to the HighJump virtual terminal, connects to the process that we're trying to execute in this case, which is ASN receipt, and actually performs the necessary test steps within ASN receipt. There you go. You can see the script is done. All is green. We ran 18 test steps, of which 0 wrong, and the script took about 29 seconds. The script is trying to connect to the next process in the background and execute that process. When you see Advantage Engine down, that means that the script is actually resetting the device, and there you can see our process actually passed, which is blind receipt. Ran 38 test steps, of which is 0 wrong. FitNesse is trying to execute the third script in this case. It has reset our device, as you can see on the right hand side, and our third script failed. We ran 18 test steps within the script, one of which failed. We're going to dive in later and understand why exactly did that script fail when we actually analyze our test results. The script is trying to execute the fourth script. It's just reset the device on the right hand side, and inbound order receipt passed. We ran 41 test steps, of which 0 are wrong. The script took about 31.6 seconds. Now, this is the beauty of this, guys. As you can imagine, how long it would take to actually do this manually. Now, doing this manually, when I time myself, takes me about 40 to 45 minutes. Passing parameters on the RF manually and traversing through the processes and stuff like that takes quite a bit of time. But executing test scripts in this fashion just takes a couple of seconds. You can see our fifth script failed. Ran 24 test steps, of which 2 are wrong. And our last script passed stage PO receipt. Ran 33 test steps, 0 wrong. Now let's enlarge FitNesse and actually start analyzing the results. Let's go into the failing script and understand why. So this is the reason why. So the script failed at this index point. Verify text present is trying to verify that the text invalid LP will appear on the RF, and that obviously didn't happen. Now, for demonstration reasons, we scripted for this. Let's have a look at our other script that failed. Put away LP. So put away LP failed at this index point when it's trying to verify the THU master table in the database. We historically looking for this record where the type would be SO. What FitNesse is telling us is that that record is missing. What it's actually finding is a surplus record of type IV, meaning that last night's code deployment, the developer actually broke something because we historically looking for SO, but he changed the database update to be IV. Now that's the beauty of this, and we can immediately pick up any discrepancies that we have within our script. Now let's go back to our test suite. The test suite run, that is, and analyze the result. So on top, what FitNesse is telling us is that it ran 6 test scripts altogether, 2 of which are on, or actually failed. It ran 172 test steps, 3 of which failed, as you saw. Now let's edit our test scripts, the failing ones, that is. Let's go to the failing point. In fact, let's punch edit here and go to the failing point and edit this. Item ID is what ASN receipt is actually looking for in this case. Now, as mentioned before, this was scripted for demonstration reasons, and the demonstration in this case is that the test is outdated. Hence, the test is updating his script. Now, on the other hand, our put away LP script that failed, a functional defect was raised to the developer for a code fix, and he has come back to me with a fix. Now we're going to rerun our entire test suite once again. But before we do that, we're going to reset our data. There you go. Data has been reset. And now we rerun our test suite. Now I'm not going to show this test run, guys. I just want us to focus on the results after. So my test suite is done. You can see this time around all the test scripts passed because I got the developer to actually fix the issues. Let's have a look at some of the failing points and see what happened there. So you notice that in this particular case, what the tester did was change invalid LP to an item ID, as per advice that this test step has now changed, and going forward the virtual terminal needs to prompt for the item ID. So this is a case whereby the tester just merely changed his script to accommodate that new functionality. Let's have a look at our put away LP script that initially failed because of the HU master type. You can see this time around, as per the historic expectation of HU type SO, a bug was raised to the developer asking Mr. Developer to fix the defect and actually make HU master type SO as opposed to the surplus record of IV that we were getting initially. So now this is proof, and solid proof, that our defect has been fixed. Now the key thing, guys, is that you don't go in, you do not deploy until all the test scripts within your test suite or test pack pass. Now imagine how beneficial this could be, knowing that you've got tens and thousands of test scripts ready to be executed at whatever point. Make sure that your code is green before you actually go live. Imagine how much more times it saves you from doing it manually. You know the test pack already exists, and each time you just execute the entire test pack, pick up all the failures immediately and raise the red flags to the developers, get the stuff fixed before you go live. If you'd like help in building a regression pack, setting up an automated test suite, here's our information on the screen. Do give us a shout and we gladly help. Until then, happy testing. Goodbye.